Welcome everyone to our today's session. We are going to approach now more practical side of things, really look how the data could be used. And there we begin. Our slides, or sort of our topic, is digital tools, open source as a tool to advance the IT cooperation between RSCs. I would say that's not really the topic. More that the topic is energy open data and how to use it, where to get it, and what is today's situation? What are the sort of ways TSOs and the community makes their data available, and how you, as a user, could really make your daily solution on it. So we'll be as practical as possible. We will have live coding, and I will try to sort of little bit give some theory and background on what is data and what we think about data. So just as much just that you can understand what it means. Why we are doing it? To raise an awareness. I think it's very important, both to share code, but also share data, so that you can build everyday processes on a public data that TSOs and ENTSO-E and also on the CAS side of things are making available. So it's useful, interesting, useful on the level of a normal consumer, useful on the level of big corporations. It's useful on many levels, and I think making it people aware of it is very important. So first thing to understand, what is data? And this is really about metadata versus data. So let's say if we have, I don't know, number 35, what does it really mean? I mean, it doesn't tell you anything. But maybe if you write that it has a unit of eur, then it already tells you something. So this sort of is the data. And then it can be whatever what you tell you. And we could have here megawatt hours, let's say. So this is a price. But what price is then? Then you need more. Maybe you need sort of a region. And let's say this is EE, Estonia. So you know this is about in that region. And let's say if you have a timestamp here as well, then you know that this is actually price for that moment. And maybe you have time horizons and so on and so on. So it's very important to have metadata. When we talk about metadata, people usually are used to Excels and file names. You put things on your files and name them somehow. But this is not really how you should do it, because humans can understand if you have table names and if you have file names, and they can guess what it means. But if you really want to be sure that something works, you have to have the tags there available to sort of tell you what this data is in a consistent way. What data formats are there? So mostly we are using XML. There is a standardized version, which we will go into later on, and JSON, CSV, Excel. So Excel is not really a thing to use. CSV maybe more, but those two usually don't have any metadata capability, only the file name. What to use as Python goes, Pandas and LXML are good libraries to parse this kind of data. So what is a JSON? JSON is a sort of pair of keys and values in the end. So you have a key and you have a value, and you can have this structure more. And you can see here's an example how it looks like. So you have status of it, then you say you have data, and there is sort of embedded metadata here saying that this is a region for EE, timestamp, price, and you can have multiple items in there like this. So what is an XML? XML is much more than on the slides here, but the things that you will most be interested in is that tag that is called the tag of this or name of this element. It has an opening and closing, and then you have text. This is between the open and close tags. And then you have attributes, which are telling you additional metadata about this field. So altogether, this message contains metadata. You could say that this price amount is the data, and everything above here is the metadata. But you can also have a coding scheme, which tells you which kind of code is expected to be here in this field. Then you have SIM XML. So this is Common Information Model. This is what ENTSO-E is using very extensively, taking on the work of ISC. And how this ecosystem is set up, it's much more robust. So we have EDI library on ENTSO-E website, which tells us all the schemas and implementation guides which are available. And also, that is not all. This tells you the structure of the files, but then you have the code list. So this was the ones that we were looking here on the codes. You can see all the codes are here, so you have all the availability to see what actual code means. And then this was about entities, but if we go really to the code list here, you can see these are like curve type and let's say business type, message type. Then you have a common code list. And this is not just a PDF. You actually have it available as well as an XML that you can automatically parse and get all the data out from there. So to continue, what kind of technologies are used? Most commonly, simple REST APIs. And what is a REST API? It is basically as your web browser goes to a web page, it asks data. It is a get command, and it takes from that URL and takes that. So we have different ways. We have paths. We have queries. Path is everything with the slashes after the main URL, and query is everything that you have after the question mark. Then it's also possible that you have it in a payload, meaning that instead of you going only to the URL, you have something that you have to send to the entity. The best Python library, again, to use is request here. There is also a framework called CCAN that some TSOs use, and it makes multiple APIs available. But these are more standardized. I have shortly made a list of APIs that I have picked up before these slides. And we can go over these sort of examples. Let's say we can take an Ellering example, which is a very simple system. You have no registration. Let's say you want to see Nord Pool spot price for our region or neighboring regions. And this just returns you very simple JSON. This was the same example that you saw before. There are other ways to do it. So the main issue here is that you don't really have the metadata in the data itself. You have it in the URL. So you don't have the knowledge afterwards. And really, this is just a platform to show you how it works. You can always just take the link, paste it to a web browser, and get the data in your web browser. So it works the same way. Okay, so if we go back to the... There are different ones. Let's say Tenet one is also a very simple one. It uses XML, but again, here are just basically file names here. So if we take balance, you just have a fixed resource available on the web page, and this is now not anymore JSON, but XML. Again, you have a little bit more metadata here, but most of the metadata is in the tags of the XML. So this is also not so perfect. Exactly. Then we can look at more advanced ones. Let's say National Grid is using this CCAN as a background. And here, in the end, you can see you can even put into this query SQL query parameters. And you have a very complex metadata structure that you can ask and query for. We will go to the ENTSO-E one later on, which we will be using for the example. Okay. So this is about URL, so that you know. And then it is about time. So something to understand about time is people are quite used to sort of notion that, I don't know, I have 14 o'clock and I have value, let's say 10. And this is quite usual notation of time. But this is not really true in the sense that, which is it? Is it the time from 13 o'clock to 14 o'clock, or is it from 14 o'clock to 10? So actually, we almost never really talk about timestamps. So if we think about time, we have those hours here somewhere, or whatever time horizons they are. So we don't usually have the 14:00. We actually have periods of time. And when we say that something is a value, it is not value at point here. It's actually value between those two times. So it is always necessary to be sure that you know your alignment, meaning that does 14 o'clock mean 14 to 15, or might it even mean 14 to 14:50? It's much better to notate always with the start and end time. So a time zone, also very important. Many people forget time zone and why time zone is needed. We have daylight saving, and when time zones shift, we can have same hour multiple times. And if you do data processing, if you have in the index of data same time, you cannot really use the data or be sure for which hour we're talking about. Then we have time formats. So ISO 8601 doesn't tell anything, everybody, I guess, but it's a standard format that almost everything today supports. Then we have Unix timestamp, and then we have a lot of custom ones, which are regional. Then what time is used? Usually UTC, which is best. If we query, we don't have to deal with the time zone differences, but also some systems use local time. So just to show what is Unix time. So Unix time is a string of seconds from January 1st, 1970, which was the date when the first Unix system went live. At least I believe this is so. And then on ISO 8601, you can read on Wikipedia. This is basically today's standard of format. You can see it on the side here. So it uses dashes and colons, and it also, let's take international one. Yeah. So the format really talks about date time in different ways, but if you think about it, it defines, you can read it from here longer, but it is really standardized and used everywhere, and the normal notation looks like this here. Okay, Python libraries to use. Datetime is a built-in library. Poo time zones, boots is where time zones are kept, and pandas is also supports most of them. So what is Git? Git is basically, if you have no knowledge of it, it is a public Dropbox for code. And you can see all the changes, and it has a lot more functionalities. Today's code I'm keeping on GitHub, which is one of many hosting entities of this kind of software. You can have a wiki here, but that's not main part of the Git. The main part of the Git is you have code here, and you can really see it live here. You can see the raw data, and you can see the history of the data. And you can pull it from here. You can share, make your changes here. So that is the main thing. So today, if you want to already use the code that is made, you can either download the zip file or use the git command on your system or software and download it, and then you have always possibility to sync with it. Okay, so now we go to live demo. I said what could go wrong. Usually live demos go wrong. And let's see. Okay, so maybe we will start with something simple. So let's start with something simple, like we had this Ellering example. So if we have something simple, sorry. Let's go to Wiki and let's go to this Ellering example. So here we get back a JSON representation of this data. And we don't have to pass any parameters, it's just the URL will give us the latest data that is available for 24 hours. So if we go here, we can import requests, say that our URL equals this API, and now we can just use requests.get, and here goes the URL we want to get the data from. We'll initiate. Okay, so we get back response 200. 200 is a code for successful exchange on the HTTP. So, but it's just good to know. So let's say we have response here. And now we want to get from the response the data actually. So the raw data we will get like this, because we know it is in a JSON format. So if we just get response.json, now we see what's in here. So we have data, and let's say EE, V, LT, and some timestamps. Yeah. Now if we want to do something with it, let's say this is our raw data. Okay. Then, yeah, we can do import pandas. Okay, let's do it on another slide. Let's run it again. Let's add another step here. And import pandas. So let's say we have the raw data, and we have to say where we want to go in. So it's a JSON, we navigate with this brackets there, and the first element was data, and then let's say we want to get for the Finland area. So this should give us a data frame of Finland area. So now we have something here. This timestamp now doesn't tell us a lot. So then we would need to find what is pandas Unix timestamp to datetime. Yeah, so here we can always find on internet all good things, and this one seems to be a good one. So we can go to here and say that if this is our data, now we want to change the data dot, what is this? ISO UTC time. We need to put brackets here. And we will take this example we had here. We have to change the call, so it is pandas. And here as well. And the thing what we want to do is timestamp. We want to counter. Okay, let's see if we get something more useful now. No. Sorry. So here it's not pandas, this here is our data. And we need to bring something out to see it as well. Okay, so now instead of this, having this non-understandable timestamp, we actually have some sort of UTC time. But this also doesn't contain the time horizon, or the time zone. So I think there is this kind of thing. We can put UTC equals true, and now we get the actual timestamp. So this plus means where it is. And if we would now like to visualize the data, so we could take data. Let's see, we should set index. So data set index, and we will set index this UTC time. And we can select the column which we want to see is price. And we can plot it. That might work. Okay, we got a small plot with the prices in this region, timestamps are there. We can probably do something like this, figure size equals some parameters, let's say 20 by 10. Yeah, now we have it bigger. And we can also be nice and tell about the, let's say, y-axis is basically eur per megawatt hour. So then we know what it is. Okay. So it seems that it's not that one, but I think I want to go to another example, so we'll leave it to be at the moment. Okay, so this was an example of a very simple one. You can see it's only a few lines of code to actually get useful data to do something with it. You can always export the data. You can do multiple things with it. So now we will go to the ENTSO-E one. And the issue here is, as you can see, the data really doesn't contain any metadata. So you have no way of really knowing. Instead, only the URL tells you something about it, but it doesn't tell you which period, what process, so on and so on. And we will see now from the ENTSO-E side how things are done differently. So we have the link for the API here. But I think the first thing to do is, if you have registered yourself, you can log in to ENTSO-E Transparency. The home page looks like this. You have some data available here. You can explore it, and so on. You can look at generation, let's say forecast of wind and solar, and take some area, and you can see the data. But this is not really useful if you want to do some automation on it. So what is enabled here is that once you have registered, you have your account, and here you can request for the API key. And this one can be used today. I will change it later on. You will have also some monitoring on it. So first thing first, we need this key for sure. And let's start with this, that we have the API key. Okay. So what else we need? now we should go to the here and look what kind of methods we have here available and how does it look like. So all the implementation is here, time formats, everything is here. So we have to see, okay, so in production, the main place is this one. So we can say that this is the base URL. Okay. What else do we need? We need to know how to ask data. So let's take some sort of example. We first need to also know how to authenticate. So let's say authentication and authorization. So first parameter is that we need to have, as you remember, the question mark after the URL tells you the parameters. So now when we start to make the URL, let's say we have the query URL. Python has this nice way of formatting things if you use f string. So it's f before the string. 2 columns is the 2 quotas is a string. So we can say and use brackets here. We can use base URL. And this will just retrieve us the query URL if I write it here. So we should see the same thing which we wrote in the base URL. Let's wait for it to load it. Yeah, typos are bad. Query URL. Okay, so this is just giving us the same thing. And now if we start to add here things, so what we knew there was this, that we need to add the security token there. So let's make this one also variable. And let's say this is API key. If we run now, then we will get longer one with the token. Maybe we can put here print, then it works as a... Now we need to query something. So what would be interesting to query? Let's maybe go also with the prices. So because if I now click this one here, it really, I mean, there is nothing defined, so it doesn't return you anything interesting. So we have to do something that gives us something. So let's find here something like prices. Let's say day ahead prices. Okay. And here we have an example query already here, and we have already the GET request. This is by the URL. We also can have a payload. So this would be an XML payload, and this is the expected response. Okay, so let's take this example query. And let's add it here. So I can just paste it here, and I need some ampersand sign here to distinguish the parameters. Okay. So now I should have an actual time series. So, but this is a quite long period. You can see it's from 2015 to 2018. So let's take something more recent. So let's change the date from 2020. What is today? 11th, and let's take from 23rd then, and the same to there. So 6 characters. Yeah. Okay. So let's run it again. We have a link for a different time period, and now. Okay. So not available yet. Did I put something wrong? Oh, I put the same time. We have to have a little bit difference, so that should be 24th. Okay, so now we have data. And we can now come back to this metadata and data question. So you can see it might not be first very readable, but basically you have the root element, which states what kind of document it is. It states also basically the language, because you know from languages you can have the same attribute name or same words in different languages, and this is basically stating that this is public market documentation from this domain. And you can see this is the ISC, and there is this organizational where it is, working group 16, and also the slashes or what it is, then the specific document. And as stated before, you can find all of this on the ENTSO-E library. So if you look here, you find all the documentation about these formats. So this is a unique reference to this ISC specific one. Okay. And here we have basically what kind of message type it is. So we wanted to know what is like a message type A44. So if we put it here, so let's find what it is. We need to go. The codes are multiple. Yeah, so this is a price document. So you have the document code list of message types, and here it tells you that it's a price document, and if you want to use it in your system automatically, you can take the code list XSD that's available on the web page. Okay, so now we can go back and we need to start getting the data out of here. So here is all the in and out domains, sender, and so on, but what we are really interested in is data here. So actually the data element is this one here, but we need to go through the whole XML to get to this data. So first thing first, we again need to get the raw data. So again, we import the requests library, and we need to get the, let's say it returns us a response, and it's requests.get, and we have this query URL. So we don't have to do it multiple times. It should return us, yeah, let's write the response so we know that we got the data. So if it is 200, it's good. Okay. Now we really need to sort of use the data. And as it's an XML, there are different things, but I will be using LXML library. So what is E3 is element tree. So if you think about the XML, as you saw before, it's sort of element tree. It has its sort of root and then children and another master and children and so on. So you sort of look at this an element tree, and the thing to use is a library called LXML and element tree. So yeah, let's try something. So first we need to get the data out of there. So yeah, how to do it? Response should have the data, so there should be content. Yeah. Okay, let's see what the content is. So content is a string. Okay, so probably our raw data is E3 dot from string response content. So let's see what now the raw data is. Okay, perfect. So what we got is that it found the first element of that tree. Now we need to now this is only an element, so it doesn't really know about the tree. So we need to somehow make it more aware of its structure. Because if we want to now find something, let's test it. So raw data, find all, and we were interested in the points per se. So we are actually interested in this point. To find everything anywhere, you need to use this XPath syntax, which is something like that. But it returns us nothing. So actually, we need to get first the get root tree, so that we know that the tree is there. And this should give us something more. Okay. Let's do it like this then. Tree. I know what is issue as well. We need to also define the namespace that we were talking about before. And to do that, we need to use curly braces and put a star there. And So this is the way that it should be there. I'm missing it on my keyboard. So let's go back to there. Okay. So it didn't find anything, and we need to get this again, the raw data, get root tree. And if we have that one, we should have all the points in the system. It's one period, we had to do a point. Okay, so here we have all the points with their namespace, and we have all the points. So what can we do next? We need to get the data from the point. So let's say we have the points here, and now we want to get for point in points. We want to get let's print point dot find, and we are looking for, so we can look here again. What we are looking in the point, we are looking for price amount. So we want to have price amounts available. Because now we don't have to move in the, you can think about the tree structure like a file structure. So this would be your first folder, and there would be files in there, and then you would go in and in. So first, when we wanted to find something everywhere, we had to use this notation. But now it should be enough to just have the element name with its namespace, and star, always asterisk, actually means any namespace. So let's see. Yeah, now we got price amount, but we didn't get the value. So how to get the value? So if you remember, it was dot text was the one that was called the value. And now we have all the values. But what to do with that? I mean, now we have the values, but we are missing all the metadata. So this is actually the data. Now we have all the data there, but we don't really have any metadata available. And we don't even know from what time to what time it is. So probably the points is not so interesting for us. We need to get actually something that contains already data about the points. And that you can see that we have the start and end interval, resolution and position. We have them all in the higher element. So actually we should find all the periods in the message, or even all the time series to really do something. But if we can have multiple periods within the time series, so let's go with a period. Okay, so let's move this previous part of code somewhere else, and let's deal with periods. Okay. So our periods equal the same raw data, but now we're not looking for points, but we are looking for periods. Okay. And what do we do with each period? For period in periods, we actually want to get some data from there. So what data we want to get? We want to get start time to really get some understanding of end time. And we want to get resolution. Okay, how do we get them all? So in the end, it's all, again, this find function that we need to use. So now we don't use find all, we find just we want to get one result, and we can go now and select what is here. So we know it's start, it's our start time. We should go again into the structure, but because I'm using this find anywhere in the beginning, I can just use like this. And also I can do the same thing for the, and we have to find it from somewhere. So we have to say it's a period where we are finding it from. So period find start, period find end, and what else was here? Resolution. Okay. Okay, so, and here we should find it right away. Now the question is, do we have some structure to keep the data? So let's make some structure. So we can use a list, let's say. Data list. And we can use just brackets here. And we want to then append this somehow there. Let's then, data list dot append. So we're adding an element there. And we are adding, let's say, a dictionary or a list. We can use a dictionary. Then we have meta keys there. So it's a start, end, resolution. And we have to assign them values. Here goes start time, end time. Why we put it into curly brackets is then we can have the metadata there still. So let's print out this data list. Let's see what we got. Yeah, so we can see we have element start and we have all the elements, but we don't really want the elements. We want something more useful. Then we have to use this dot text again. Not to just get the element, but the element values. Okay, now we should have, so we have the start, end, and resolution. As you see, each field actually tells you what it is. That's good. Now, what shall we do with it? We need somehow to get it. And we can show already if we put here a longer period of time, we will, we will get different kind of more time series. So today it was only one, but let's say we have, I don't know, from 20 So we have 4 days of data should be there. So if we now run all the steps again, we should have more. Yeah, you see we have more time series. We don't have only one anymore. And how it looks here is the same. We have now multiple time series available. Okay, so let's go back here. Now we need to do something with the data. So we know that in each period there are actually points as well. So we can use this find all points again. So we have points equals, and now we are looking it in a period. In this specific period, we are looking for all the points available. And for each point, we want to get both the amounts and okay, so we want to know the value, which is data, and we want to know the position of data because we don't have the start and end time there. So here goes the position. Okay. Let's print it out. Let's see. Now we should have all the values. Some curly brackets left over. So we have now everything with their positions, but that doesn't really tell us a lot. So we should now find somehow the time horizon there. And this we need to parse the data to something. So for that we should first import a library. So we can use pip import to import something. And this, install. This is how we can, in this environment, load libraries that are not there. And we can then import that library. Okay. So now we need to do with these things to make them something. So actually, this is a float. So if we want to keep it as a float, not a string, we have to make it into a float. If we want to keep this one as an integer, so we put it in an int. And now we also want to make these to actual times. So we have to use this new library that we imported. And use parse so that it could get the date time, and we will use it to all of them. Okay, I think we are not able to finish the demo in this slide, but the data is up on the Git. We didn't have time to go through it fully, so I will show you just the end on the Git version. First of all, one moment. Yeah, so here we have the actual code available on GitHub. You look at the Open Data ENTSO-E example that's on the Git, and you can see more of the parsing, and the end result is we get the same kind of data, but also with the metadata. That is, I think, the most important part. What we have to think about if we build some APIs, that we think both about the data and the metadata and the formats. Thank you all. That will be it. Follow it on your own pace at home, or write me if you have questions.